Welcome to the Northeast Clean Freight Corridor Workgroup discussion on gaseous and liquid alternative fuel technologies and infrastructure. My name is Alicia Gildy, and I'm the Northeast Regional Director for CalSTART, a national clean transportation organization. I'm also the co-chair of the Northeast Diesel Collaborative Strategic Planning Committee and our working group. I am here joined with our Northeast Diesel Collaborative Planning team, and we are excited to introduce the second webinar of the 2017 Northeast Clean Freight Corridors Roadmap, and we have quite a lineup for you today. First, I just want to start off with a little housekeeping, and that is, one, we have a number of presenters today, and what I would like to do is hold questions toward the end so that we can get through all of the great presentations that we have in store for you. So as you come to think of questions, please go ahead and enter your questions into the question box. Abby Swain with EPA Region 1 is going to be coordinating the questions and making sure that we have them down and ready once we have our discussion at the end. Also, toward the end of the webinar, when we get into the workgroup discussion, if you're interested in taking part of the conversation, make sure that you've entered in your audio pin, and I can easily unmute you so that we can hear you. Then the second thing I would like to mention is that we do have the PowerPoint presentation attached to the webinar. It's a pretty big one. Will be a little difficult to send via email, so please take advantage of the opportunity to download the presentation just by double-clicking twice, and that should work for you. All right, so let's go ahead and get started. All right, so I will first just show you how we're progressing against our roadmap. Again, as I mentioned, we're at number 2. We have 5 webinars set up for this year before we head to our Northeast Diesel Collaborative Partners meeting. And then we'll get right into a deep dive of looking at our gaseous and liquid alternative transportation technologies and fuels and the infrastructure and what that means for the Northeast region. We have a number of great presenters, and we'll get to that. And then we'll have a really good workgroup discussion where we want to hear your questions. We want to figure out how we can work with our partners to advance our infrastructure to promote the adoption of these fuels in the Northeast. All right, so here's our 2017 Northeast Clean Freight Corridor Roadmap. This is the second webinar here. You can see highlighted, I have the arrow in orange. Our next webinar heading up in July of 27th of July will be focused on electric powered trucks and intermodal idle reduction technology and infrastructure. So today we're going to be talking about fuels, gaseous and liquid fuels. Our next webinar we're going to be talking about electric hybrid and TSC technologies as it relates to our corridor efforts. So stand by for that, and certainly look forward to putting together another good lineup of presenters. All right, what would we like to achieve today? Well, first we would really like to understand the status of gaseous and liquid alternative fuels for freight in the Northeast. We want to get a good understanding of the existing infrastructure. We want to hear from our partners in terms of the fleets and end users that are utilizing these fuels, kind of understand the benefits and the cost benefits of these fuels and what it means to moving this industry forward in promoting the adoption of these fuels with other users. And then really looking at the opportunities to expand infrastructure growth and figuring out how our working group can be a part of the solution. What can we do to help you expand the adoption of these technologies? What does it mean in terms of our planning, incentives, and just really understanding all of what it takes to implement alternative fuels. All right, so you can see here we have 3 different fuel types that we're going to be talking about today. We're going to be talking about compressed natural gas, renewable natural gas, liquefied natural gas. We're going to be talking about hydrogen and biodiesel. You can see that we have a number of really great speakers who have put in some valuable time into their presentations and certainly have a lot of great value to provide to you today. Everyone has 10 minutes to present on their topic. What I've done is I wanted to make sure that our Clean City coordinators who have been instrumental in our Clean Corridors efforts, I've invited them to help introduce our speakers today. And so you will also hear and learn more about them and the great work that they do as well. All right, so with that, let's go ahead and get started here. First what I'm going to do is I'm going to introduce my good friend Barry Carr, who is going to be then introducing Bill Zobel. Many of you may know Barry. Barry is the regional manager for Westport Fuel Systems. He's also the Clean City coordinators for Clean Communities of Central New York, and he's been the coordinator since 2004. Barry has recently been awarded a Lifetime Achievement Award from NGVA America, and he also received an Outstanding Leadership Award from the U.S. Department of Energy Clean Cities Program. Barry, I'm bringing you to this next slide where I have you holding a flag, and it looks like you've made it to the end of a race. So maybe you can share a little bit about that with us, but I hand it over to you, Barry.
Okay, thank you, everyone. Thank you, Alicia. I'm Barry Carr from Westport Fuel System Solutions, and if you'll hear the background noise, I am at a NAPA event at a baseball game in Philadelphia, so bear with me. But besides thanking Alicia and her group for all their hard work, and believe me, very few of them are being paid to do this. After I introduce Bill, I also want to thank Leo Cortizo, my good friend from Clean Energy, and all of our other infrastructure partners that you should be aware of, like American Natural Gas, Spire, Gain, TrueStar, and then lots of other small ones. But certainly Love's Trillium and Clean Energy are the largest supporters and developers for natural gas infrastructure in the United States. I also want to urge all of you on behalf of the DOE Clean Cities program to work together, collaborate as much as possible. And I know we have some other coordinators on the call, but specifically in our area, we're talking about Maine, New Hampshire, Vermont, Connecticut, New York, New Jersey, Pennsylvania, and down into Maryland, Virginia, DC, and Delaware. I had the opportunity and the good fortune of being part of a natural gas vehicle marathon road rally last week. So I found myself driving 2,100 miles in 42 hours and visiting 7 different states. So it's important to continue to do this, and it's important to collaborate. So next I'd like to introduce Bill Zobel. Bill is someone I've known for quite a while. He's the Vice President of Business Development, Marketing, and Customer Care for Trillium. Trillium is now part of the Love's family. So Love's, that has truck stops nationally, has come in and is supporting Trillium as they move forward. Bill has, we have a lot in common as I read through his bio, but he has nearly 30 years of experience and managed at one point Sempra Utilities' natural gas and electric vehicle clean transportation program, which I worked on back in the 90s. He is also on the board of our trade organization, NGV America, and was also part of a group under the Obama administration, Energy Secretary Chu, to develop the Future Transportation Fuel Study. And Bill, you don't remember this, but I worked on that as well. Bill's background is that he holds a Bachelor's of Science degree in Chemical Engineering from Cal State University at Long Beach, and he's a graduate of Columbia University's Executive Business Program. So Bill, go ahead and start your presentation. I'm going to go on mute, and thank you again for agreeing to do this.
Barry, thank you. Enjoy the game. Thank you, everybody, for making time today. Appreciate it. I know everybody's busy. I'm going to spend just 30 seconds here shamelessly advertising my company. Trillium is, as Barry mentioned, one of the larger CNG providers in the U.S. We've got a very large network. We operate over 180 stations across the country. Barry mentioned we are owned by the Love's family of companies. The Love's Travel Stops is the largest recognizable brand within that family of companies, and they are one of the largest privately held companies in the U.S. Go ahead 2 slides, Alicia. Sorry about that. I forgot to ask you to move that forward. One more, please. We provide a full slate of design and build services for folks across the country and a host of value-added services, some of which we'll talk about today, like renewable gas, some of our P3 expertise, gas procurement, and so forth. So at the outset, Alicia talked a little bit about kind of where we are on an infrastructure basis in the northeast part of the country. This map, while it's a little bit hard to see on the webinar, is available on the website, and you can zoom in and see other locations. But it does demonstrate where we are really on the footprints of the United States, and the Northeast is certainly an area that we'd like to spend more time. And we think that this program provides us a real good opportunity to do that. Next slide, please. So let's jump right into why CNG is a good value and a good value proposition for this program overall and for fleets across the country. First of all, CNG is a low-cost transportation fuel, and I've got some slides to help demonstrate that. But importantly, for fleets that care about knowing what their costs are going to be, it provides stable long-term fuel prices just based on where the commodity comes from and how that commodity is priced. Next slide, please, Alicia. So this chart is from the Department of Energy Alternative Fuels Data Center. And what I'm trying to demonstrate here is really not so much the differential between the two fuels. You've got diesel and gasoline there in the blue and well, two shades of blue. And then you've got CNG down there on the green line. What you see here is that CNG prices are very stable. They don't move around much. And if you look at all the forecasts forward, the prices will be extremely stable going forward well into the next decade or two. What helps that is that at the pump for compressed natural gas, the percentage of CNG commodity that's part of that pump price is very small, about 25%, where other petroleum products, it's more like 60 to 70%. So when you have variations in commodity on the petroleum side, you don't see those so much on the gas side. Next slide, please. So CNG is also the cleanest commercially available fuel for medium and heavy duty vehicles. And let me talk a little bit about that on the next couple slides. Let's go to the next slide, please, Alicia. So there are 3 engines that are available for the medium and heavy duty sector that can move just about any freight duty cycle that's out there. You've got the 6.7 liter engine, you've got the 8.9 liter gas engine, and then the 11.9 or the 12 liter ISXG gas engine. The engine there in the middle, the ISLG, is now certified at a 0.02 NOx standard, which is the lowest standard of any combustion engine available on the market today. The ISX12, the engine just to the right of that, the larger one, and this can serve the majority of the over-the-road and regional fleet movement sector, is also going to be at 0.02 certification in the first quarter of 2018. So first part of next year, we'll have 2 very large heavy-duty engines that are available. The 9 liter, as I mentioned, the 8.9 liter is available today. And these 2 engines produce the lowest emissions commercially available for fleets. Next slide, please. This chart simply demonstrates where the emissions on these engines compare to other engines. So you can see the block in the back there is the 2016 EPA standard. And if you look at the NOx is on the vertical axis there at 0.2. The ISLG gas engine, that's the 9 liter, that's currently coming in between 0.1 and 0.15. They've got that now down to 0.02, which is the green box down there on the bottom. So that's where that engine operates today. And these engines are available for transit fleets, refuse fleets, and a variety of other regional haulers. The larger engine, as I mentioned, the 11.9 liter ISXG, one of the previous slide, all the way to the right, will be available at that same emissions level in the first quarter of 2018. Next slide, please. Adding to the environmental benefits of natural gas is the renewable footprint, or the carbon footprint that you can get with renewable natural gas. Let's go to the next slide, please. This slide is a chart taken from a report done in California that shows the California Air Resources Board carbon intensity numbers across the spectrum of fuels, starting from ultra-low sulfur diesel all the way to the left, all the way down to some of the cleanest renewable gas sources over on the right, and demonstrated in the green bars. And what you can see here is by integrating renewable natural gas into the natural gas stream for any fleet or commercial application, you can reduce your carbon footprint of that fleet several-fold, down to what could be, using some sources, almost negative of where it was when you started. So there's tremendous potential for the marketplace to move renewable gas into the transportation space. There are both federal and in some states programs that allow you to monetize the value of this gas and bring down the cost of your fuel even further. So if there's an interest in reducing your carbon footprint, providing additional sustainability to your logistics portfolio, and in monetizing renewable fuel to bring down the overall cost of your fleet, renewable CNG provides the opportunity for you to do that. Next slide, please. So this is part of where the rubber hits the road. At this time, which is kind of a remarkable time in the history of alternative fuels, there's never been a better opportunity to take advantage of state and federal incentives to help convert a fleet over to compressed natural gas. And the benefit of this program, this Clean Corridors program, is going to be to leverage those funds as best we can to the benefit of fleets and private consumers that are looking to move over to alternative fuels. So now is the time for us to take this domestically available fuel, move it into the marketplace, and do so with what are the best incentives that have ever been available in the marketplace. Let's jump to the next slide. We'll talk a little bit about some of those incentives. So at the federal level, for those that haven't heard about the Volkswagen settlement, VW was caught cheating on their emission profiles for some of their vehicles. Long story, you can look that up on the internet and learn everything you want to know about it at the source I have listed down there at the bottom of this slide. But the end result of that is that Volkswagen is going to pay a bunch of money to the federal government, and the federal government is going to distribute that money to the states. Specifically for the folks on this call, you can see when you look at this chart the amount of money that will be available through state agencies that can be directed towards alternative fuel vehicles. Now, these monies are only available to vehicles. They're not available for infrastructure, but if the vehicles are there, the infrastructure will follow. So starting on the left, you can see Rhode Island there is about 14 million. You've got Maine in the second column at about 21 million, Connecticut at 55 million. New Jersey's going to get 72 million, Massachusetts will get 75 million, and New York's going to get about 127 million. There has never been this much money available ever in the history of these alternative fuels to try and move some of this money into moving additional vehicles onto the road, and the infrastructure will certainly follow. Next slide, please. So lastly, in the last 2 minutes, I'm going to spend some time just talking about some recommendations for this team on how they can move the market forward. So in terms of Clean Corridor policy recommendations, the starting point will be to clearly identify what your goals are. And here it's obviously to improve air quality, but importantly, it should be to develop convenient, customer-efficient refueling infrastructure. We need to make sure that we're putting this infrastructure in places where people will use it, not necessarily where a city or municipality wants to deliver it. It has to be convenient, has to be available along the interstate and available to a wide variety of customers. As we move down the road, you want to make sure that we rank and prioritize these projects, first of all against the goals that we have, and then one of the best ways to do that would be to rank them on a cost-effectiveness basis. And a lot of folks use dollars per ton for those kinds of reductions, and the chart or the graphic that's provided over here on the right side of this slide is one I've taken from NGVA. The source is listed down there at the bottom, and that's certainly one way to help distribute these dollars. The last piece of this is what I call commercialization, which is let's do what it takes to move the market into the mainstream. And that means building infrastructure where folks will use it and to maximize the potential of that infrastructure money when you couple it with the vehicles. Next slide, please. So again, just to recap on some of the funds that are out there, I touched on the VW funding a little bit. We had limited time, so I didn't go through the DERA funds. I'm sure most folks are familiar with that, and there are a variety of state programs that vary state by state. But coupling these programs together into a bundle that can be utilized by fleets and other folks to move into the alternative fuel space will be the most effective way to utilize those dollars. And finally, to expand the role of the Clean Cities programs and coordinators. These are regional folks that are regional experts. They know the fleets and customers that are interested in moving over to alternative fuels. And I think they can be used very effectively to align funding with prospective customers. I know we use them, but we don't communicate well with our competitors for obvious reasons. Using the Clean Cities coordinators or the Clean Cities organizations as a conduit between competitors could be very helpful in identifying who and where would be the best locations to put fleets and direct vehicle dollars. I've got one last slide, just kind of a wrap up here. Last slide, please, Alicia. Just to recap then again on the value. So CNG and renewable natural gas are very cost effective. They provide near zero emissions on NOx for point source emissions. It's a very low carbon fuel if you're using the renewable option, and the fuel is domestic, all things that are very good for our economy. Here in this program, I think we need to do everything we can to leverage all the available resources, and that includes all of the federal and state incentives and the Clean Cities people to help bring these things together, and the timing has never been better. And with that, I'll turn it over to Susan.
Bill,
Thank you,
so
Bill.
much. Take it away.
Go ahead, Alicia. So next up we have Leo Cortizo, who's the Business Development Manager, Clean Energy Fuels. And why don't we just go straight into his presentation. Leo, are you ready?
Yes, thank you, Susan. Thank you, Alicia. And thank you, Bill. Bill and I did speak before we started this thing, and even though we are competitors, our ultimate goal is to have a corridor that is filled with options for our customers. So thank you as well. Let's start off. Next slide, please. So I'm going to go through who we are, Clean Energy, who Clean Energy is, understanding the challenges, the benefits of natural gas, fueling the transportation industry, what does it take to be successful today, and then heavy and medium-duty trucking, which is an area of particular interest to me. Next slide, please. So my 30-second shameless pitch. Clean Energy is the largest transportation alternative fuel provider in the country. We have 970 fleet customers, over 970 fleet customers. We do over 9,000 transactions a day, 45,000 NGVs fueled daily, and we own or operate over 550 stations. Next slide, please. Clean Energy also owns Clean Energy Compression. We build compressors. Clean Energy Cryogenics, we build LNG and LCNG stations. And Clean Energy Renewables, which sells our trademark product, Redeem. Our Redeem product has been on the market now for 2 years and is doing very well in the renewable space. We've also partnered with NG Advantage, or a Clean Energy partner, to provide natural gas in locations where there isn't pipeline gas available, and they deliver large industrial sites gas so that they can use it instead of coal and or diesel. Next slide, please. So today's challenge, with fuel costs being as volatile as they are and environmental concerns, energy independence and conservation are high priorities for our country. Today we're going to talk about the economics of gas, foreign dependency a little bit less, because natural gas is mostly comes from our country, and then the environmental issues with greenhouse gases and NOx emissions. Next slide, please. The economics are very simple. If you look at the slide here, for the past 8 years on an MMBTU basis, you can see that natural gas has been relatively stable, and if you look at the diesel line, it's been all over the place. Today we are in a relatively low diesel environment, but as we all know, that could change. And so even though some market conditions have made it less volatile, it is still volatile. And if you're looking for budget stability, natural gas is still the best way to go. Next slide, please. And why is that? Well, if you look at the graphics here, 58% of your commodity price in diesel is the commodity itself. With LNG and CNG, it's significantly less. So even if there is a price fluctuation, because it is significantly less, you are paying less to pump for that movement. And so LNG and CNG, again, for stability's sake, are the best options. Next slide, please. So we offer all of these fuels, which is CNG, compressed natural gas, LNG, liquefied natural gas, which is super cool gas stored in a thermos, basically, and then Redeem, which can be sold either as CNG or LNG, and that is that renewable product I mentioned earlier. Next slide, please. What are the benefits of switching? Well, if you switch from gasoline or diesel to natural gas, it saves you money, you can dramatically reduce your emissions, and it benefits everyone. The community has quieter, cleaner vehicles on the streets. So economical, it's abundant. We have a lot of natural gas in this country, not including our renewable sources, and it makes for a cleaner environment. Next slide, please. So people always say, well, how much cleaner? I'm going to show you a slide in a second. It's significantly cleaner. Safe, there's 17 plus million vehicles around the world fueling with natural gas. It's domestic. It's almost all of it comes from our country here. Fleets that are looking, or shippers that are looking for green fleets, it gives people that operate natural gas trucks an advantage, and of course, price stability and reduced operational costs over the long term. Next slide, please. So we talked about cleaner. How much cleaner? Well, if you took 50 diesel trucks and converted them to natural gas using conventional natural gas, and we used, this is our own proprietary calculator that we have on our website if you want to check it out. So if you took 528,000 gallons a year, so that's 50 trucks, that's about 12,000, 13,000 gallons a year per truck, and you change it over to natural gas, you'd reduce your greenhouse gas emissions by 987 metric tons, which is equivalent to planting 25,000 trees or removing 200 cars from the road, or 354 tons of waste recycled instead of being landfilled. The next slide, please. If you used RNG, renewable natural gas, for our Redeem product, it's significantly more reduction in greenhouse gas emissions. And when you look at those numbers, I mean, I actually said, people say you save between 70 and 90%. So I asked our internal group that does this, and the reason that it's 4906 is because people are going to say, well, if it's 70% more, why do you have 900 on one slide and 4,000 on the other? That number is against the baseline. So 50 trucks would produce about 6,400 metric tons, and that is equivalent to that 70% savings we talk about. Next slide. That just reinforces the previous one, so we're going to punch right through that one to the next one. So fueling the transportation industry, what does it take? Well, if you go from the well or from your renewable source to the station, you need pipelines, you need the plants for the LNG, you have to have local utilities, compressors, the fuel itself, and you have to get to the station. So what do? We build those, we have plants, we provide gas, LNG, we have stations. On the CNG side, we build compressors, we work with local utilities, we work with the pipeline operators, and we make those stations convenient to use. Next slide, please. A little lag there. But none of it matters if you don't have an engine. And as Bill said earlier, this new Cummins Westport near zero emission engine is a game changer. That engine is going to make it so that if you use that with renewable natural gas, you are driving the cleanest engine available today. Next slide. For those of you on the call that don't know, there are two types of stations, and this is important. So there's fast fill stations, and those are your on-the-road stations. Those are the stations where a truck pulls up, fills up, and then continues on the road. And then you have time fill. And time fill stations are where you have an opportunity or a window to fuel your vehicle, and that vehicle's parked for several hours, and it fills up. Next slide. I don't want to go through the components of each station, but I know many of you are going to download these. So for those that don't know, there is a difference between a CNG station. The gas is compressed, it's put in those tubes, and then it's pumped out to the truck. Next slide. An LNG station, the gas is cooled at an LNG plant. It is pumped into that storage container, and then it's pumped out to the truck. And then next slide, please. And an LCNG station, the same as an LNG station, except it has a vaporizer. It heats the gas, it puts the mercaptan in it, and then it sends it out to the trucks. So anybody has any questions about any of those stations, please feel free to ask me later, but I don't want to take too much time with that. Next slide. So what are the differences? LNG is a diesel-like experience. It's fuel consistency, no problems at all. It's 100% free of impurities because they super cool it, no water, no compressor oil carryover, none of those problems that you have. And boil off is no longer a concern. LCNG, again, fuels quickly, not as quickly as LNG, but it fuels quickly because that gas is just heated up. You have the same quality of gas because the inconsistencies or the impurities have been removed. No problems there. And then you have your CNG stations. And again, 7 to 10 gallons per minute is not bad. Easy access to the stations. One of the issues is that since gas is heated up, it goes through a tube. You do lose a little bit to the heat of compression, but again, if you properly size your tanks, no big deal there. And then, of course, you have to worry about water, compressor oil, and natural gas liquids, but if you manage your filters, no issues there. So compared to diesel, it's very manageable no matter which fuel you use, whether it be LNG, LCNG, or CNG. Next slide. And then the question is, what is success? Next slide. Success is satisfying our customers' needs. So when you're going to switch to natural gas, there's things to consider. You need a company to build your station. A lot of companies build stations, very good ones. So engineering and construction. You have to have the technology and equipment. This is one that's overlooked consistently, and it's unfortunate, but you need to have facilities modifications. You need to have a bay where you can work on these vehicles unless you're going to work on them outside. And in the Northeast, that is very rarely an option. So facilities modification is a big deal. It's a consideration when you're switching your fleet over from diesel, and everybody on the call should think about that because it is a cost that is rarely spoken about when you're experimenting or when you're testing, demoing vehicles, and then you have to make the transition to actually operating those vehicles. And then, of course, financing and grants, and we have a great financing and grant department, and then operations and support, a team to make sure that your station runs every day because there's not a million of these stations. So if your station goes down, it's important that it get back up and running as quickly as possible. Next slide. And that facilities mod piece, I thought it very important to bring this up. Make sure that you either find a partner to help you maintain your vehicles, whether it be a rider, a Penske, a Penn Power, whomever it is, but they need to have the facility to do it. Or if you want to invest in upgrading your facility, make sure you get the fire department on board and then you get somebody that can do the inspections and that can make sure that your facility is up to snuff with your local fire departments. Otherwise, you could have some issues servicing your vehicles. It's a very important part of it. Next slide. And then successes. Who's running natural gas? Because people say, well, it's all who's running it today. A lot of companies are running it. Honda runs it for their car carriers, Frito, FedEx. I mean, you see the list. Anheuser-Busch. These are big companies in America that are utilizing natural gas today. Not an experiment, not a science project. It is a viable way to run your cargo throughout our country. But these companies have all done their homework, and they've all made sure that they would not lose any of their value prop with their customers when they ran these vehicles. Next slide. And then, of course, the biggest and greenest is today UPS. They run the largest package delivery company in the world. They operate a fleet of close to 100,000 vehicles, and they want to drive over 1 billion miles on their NGV fleet by the end of 2017. And FedEx is coming up right behind them. Next slide. I want to thank you all for your time today. If anybody has any questions, please do not hesitate to reach out to me directly. And Alicia and your team, thank you very much for giving me this opportunity today to speak.
Leo, thank you so much. Excellent presentation. You've answered a lot of the questions I had, so thank you very much. And I'm looking forward to further discussion toward the end of our webinar today. So thanks so much, Leo. All right, next I am going to introduce my friend Lee Granite, who is the coordinator for the Greater New Haven Clean Cities Coalition. He's going to introduce our next speaker, David Edwards. But first, a little bit about Lee. Lee started the coalition 22 years ago. He's managed a number of alternative fuel transportation programs in the state of Connecticut. He also was responsible for launching a $50 million electric bus program. He was the 2004-2008 Northeast Regional Coordinator in terms of the best. In 2012, he was the Clean Cities Hall of Fame, and then last year he was awarded the Benjamin Watson Inspirational Award for the Clean Cities Coordinator Council. Lee, thank you so much for your help, my friend, and please take it away.
Okay, can you hear me?
can hear you.
Okay, good. Yeah, Lee Grant is here. I've been doing this for quite a while. I actually started taking over the coalition in 2007 after I started it a few years before. But we have been pretty fuel neutral here in Connecticut, and we've done natural gas. We've had stations. We have 5 of those that we built. We built the first LNG station east of the Mississippi, and all these stations are still running, by the way, and we've been pretty diversified. We have trash vehicles running on natural gas. We've got a heavy-duty fleet running on LNG. We have a multitude of electric vehicles here in the state and chargers around the state. And behind the scenes, we've done a lot of work to make sure that the legal sides of these things work, to include the taxation on the fuels, and the weights and measures guys, make sure they got adequate support on how to measure these fuels. And lastly, before I introduce introduce David here, we have been big into hydrogen vehicles and hydrogen fuel cells here in Connecticut, mostly the fuel cell side, but it's the mainstay of a hydrogen vehicle. U.S. Hybrids most recently, is building a dredge vehicle, which is going to be, the fuel cell will be made in South Windsor, Connecticut. We also have a electrolyzer company here, Proton on Demand, and we'll soon have Air Liquide, and excuse me for my pronunciation, coming in here to support our vehicle, our privately owned vehicle type support and fueling. And I'm going to introduce David here. David P. Edwards is Air Liquide's Director of Technology and Partnership. He's responsible for establishing and maintaining internal and external partnerships with industry, academia, and government entities as needed to advance the technology position of Air Liquide's R&D and business. 20 years with Air Liquide R&D and business, leading technology programs in solid-state storage, MOF materials, high-pressure carbon fiber vessel design, steam methane reformer catalyst development, high-temperature SMR tube development, and small-scale hydrogen production system. Take it away there, David.
Great, thank you very much, and thanks very much to the support we've always gotten from the state of Connecticut and other states in the Northeast in introducing hydrogen and fuel cells into the market. So I'm going to give an overview of hydrogen in mobility generally, and then I'm going to talk a little bit about specifically related to freight and larger vehicles. But most of the efforts that we've put in over the last few years have been for smaller personal vehicles, and that's where we'll start. So we can go to the next slide. So first off, we are at a transition point in hydrogen. The running joke with the fuel cell people is always that hydrogen is the fuel of the future, and it may always be. Well, the future is here today, and we are seeing vehicles in the States for fuel cell applications, and we're starting to see it for other applications, including in truck applications, in rail applications, in forklifts, and a number of other stationary applications, for example. So when we look back in the history of fuel cells, 2015 to 2017 will be when we move from it being in the laboratory to it being commercially available and viable. We can go to the next slide. So first off, this is a global movement. That what I'm going to emphasize is what we're seeing in the U.S., but I've added a couple of slides that talks about what's happening in the rest of the world as a reference point, and I will eventually get to those and skip over those slides, but they'll be in your reference if you pull this presentation up. We can go to the next slide. So let's start at where do we stand in the U.S. And in the U.S., California is the lead for implementing hydrogen vehicles and hydrogen fueling stations. So shown in the picture on the top left there is a Toyota Mirai, a vehicle that's now available for lease or purchase in the state of California. The state of California has 49 active stations today, and by 2020 they're going to have about 100 stations supporting about 18,000 fuel cell vehicles. The vehicle estimates are provided by the suppliers, so Toyota, Honda, Hyundai, Mercedes, and BMW. All will have cars available now or will have cars available in the next 12 months in the California markets. and they're giving us the estimates they'll get to the 18,000 number by 2020, for example. The hydrogen stations are being put in by companies like Air Liquide. Air Liquide is a large industrial hydrogen producer, and we're moving into the commercial space of selling hydrogen to individual users at stations. And in our case, we've got several stations in California, and as you'll see on another slide, a dozen stations being started in the northeast of the United States. Let's go to the next slide. So in the Northeast, we're putting 12 stations in today. By the end of this year, about a third of those will be active and the others becoming active in 2018. We're focusing on the New York to Boston transit corridor. And so we've got 4 stations planned in the New York City area, 4 stations planned in the Boston, Massachusetts area, and then connector stations in Connecticut and Rhode Island, with another station to be located in northern New Jersey. And this is our entry point into the northeastern United States through a partnership with Toyota. In order for Toyota to introduce cars into the region, obviously they need to have stations to refuel their vehicles, and we're in partnership with them to provide the stations for where they intend to sell those vehicles. And so the first one that should open up, I believe, is in the Connecticut site, which is in Hartford, and it should be opening in the next few months. That you'll see some announcements as these stations start to roll out in the Northeast, for example. We go to the next slide. So now the next few slides are focused on the international efforts. So I talked about California and the Northeast, but there's lots of efforts going on, in this case in Germany. Germany will have 400 stations by 2023 and a number of vehicle providers there. If we go to the next slide. Japan, who currently has the largest hydrogen infrastructure, expects to have 40,000 vehicles on the roads by 2020, and will have about 100 stations in that same time period. Japan has led partly because the fuel cell vehicle manufacturers of Toyota and Honda are there, but also because of their shift from nuclear to non-nuclear energy sources. They've driven toward hydrogen as their next generation fuel for stationary power applications and leveraging that for the vehicle applications. Go to the next slide. In France is focusing on vehicles that are in fleets, especially in taxis and delivery trucks. And the first generation is taxis, where they'll have 600 taxis in Paris by 2020. You go to the next slide. Denmark, a country very much driven by wind power, wind electricity, and excess electricity, is installing electrolyzers to produce their hydrogen and is also building fleets of vehicles, including busing and personal vehicles across their country. Go to the next slide. And in Korea, we expect to have 9,000 vehicles by 2020 and a matching number of stations in that same time frame. Go to the next slide. So I guess the takeaway from that is that the infrastructure that you're starting to see in the U.S. for personal vehicles is really a global movement, that the car manufacturers globally are introducing these cars now by the thousands and tens of thousands, and we would expect that in our lifetimes we'll see hundreds of thousands of these vehicles per year being sold. I'm going to give a couple of slides of what a station looks like. But our intent from Air Liquide is to have stations look and feel like existing liquid fuel stations. So it's going to look like the gasoline station on the corner. It's going to have the same look and feel. It's going to have the same interaction with the consumer, except of course we're transferring high pressure gas instead of transferring liquid. So if you go to the next slide. Here's a picture of an existing station in California that we're going to upgrade to include hydrogen. If you look kind of in the back rear of the station, that's where we're going to end up putting the hydrogen dispensers. So if you go to the next slide, which I think is an overview. If you look at the overview, what you'll see is on the top left of this, the white boxes are essentially the equipment we need to put on the ground, the compressors and the storage for gaseous storage for the hydrogen, and the vehicles will pull up behind that station. You go to the next slide. Here's a computer rendering with the ubiquitous Toyota Mirai. So this is what the station will look like on the back side of that station. If you go to the next slide, you can see what that station looked like under construction. And this station is now open. I should have a picture of the final, but essentially these are going to look and feel like existing gasoline stations. Go to the next slide, please. All right, so I know for this audience we want to talk about things beyond individual vehicles. So I have some slides on freight and truck applications, although most of these, all of these, I've pulled off of public websites and announcements from these vehicles. I don't speak on behalf of the vehicle manufacturers, but I can give you some updates on where some of these things stand. So if you go to the next slide. First off, buses tend to be one of the largest potential uses for hydrogen for large vehicles. And the reason for buses is because a bus or other captive fleets which come back to a single location for refueling, it's easier to scale by building a single station that supports many buses at a single location than it is to build a network that is required for the intercity transportation. So one thing we would expect in larger vehicles is that this model of captive fleets for cars in the case of taxis, for buses in the case of transportation, or you could think of delivery trucks or ports or other places where you had a captive regional fleet, is where the large vehicles are going to start. Eventually, as we get enough stations for intercity, you'll start to see the intercity transports as well. Go to the next slide. So here's an announcement and some pictures from a company called Nikola. Nikola has decided they're going to go with a hybrid solution that combines battery and fuel cell technologies in order to get the mileage that they need from the systems. In general, battery systems are difficult for scaling to large sizes and don't give you the range that would be required for practical applications. Fuel cells, the gaseous fuel scales nicely with the size of the vehicle and allows you to have both the power and range that's needed for the hybrid systems. If you go to the next one. Toyota made a similar announcement earlier this year that they were going to apply their Mirai-based technology to large intercity trucking, and so they had a demonstration at the show in California earlier this year and announced that they would be making a vehicle available in the next calendar year, for example. If you go to the next slide. US Hybrid has been one of the leaders in putting fuel cell technology into large vehicles, and what's shown is, I believe, a Freightliner base where they're doing some development for one of the port areas in California, I believe. If you go to the next slide, I think we have the specifics of the, yeah, so at the Long Beach site, we have the Freightliner, or sorry, the Kenworth truck in this case, that's being done in fuel cells for a demonstration at the Long Beach shipyard. And what I've shown on the left side of this is California's action plan for large vehicles. And so if you want to get a vision for how the states are working, or how the state of California is working to introduce large vehicles, this is a good model for some of the other regions that might be in consideration. If we go to the next slide. At a little bit smaller scale, and back to what are essentially captive fleets, both FedEx and UPS have development programs today that are putting vehicles on the road, both in California, I believe. But these are the case where you've got trucks doing several hundred miles between fills, but at local fill stations, for example. Go to the next slide. And then there likely are going to be questions about things like APUs and refrigeration systems for vehicles, and there have been some development programs around having those be fuel cell powered. I would direct you to some of the developers for that. That's not an area that we've particularly worked in. You can go to the next slide. And then lastly, the most recent announcements that I've seen are around larger services in the case of rail, where they're looking at using combined battery and fuel cell technologies for very large vehicles. Both of these cases are in Europe, I believe. No, Ontario, sorry, California, Canada, and in, I believe the Alstom one is in Germany, I believe. If you go to the next slide. So from Air Liquide's perspective, and I've only got a few slides left, We are trying to enable this from the infrastructure perspective by leveraging the existing industrial infrastructure for providing hydrogen to things like refineries and to pipelines to chemical plants, and now converting this over into a consumer fuel. If you go to the next slide. One of the things that we've done is we've been one of the pioneers for the Hydrogen Council. The Hydrogen Council is a number of energy companies globally that have combined together to commit to spending $2 billion per year investment in infrastructure in the hydrogen economy. So if there's a question about, are the big companies behind this? Is it a global phenomenon? Is it for real? These are the kind of indicators that should convince you that yes, these are real activities that are going to continue for the next generation. Keep going. Next slide. And so in conclusion, as we go from a few thousand vehicles to tens of thousands of vehicles, and as we go from personal vehicles to buses to taxis to larger vehicles, and as we go from stations to hundreds to thousands of stations, this will become a mainstream fuel for us over the next few years. I think if you go to the last slide. And so we've reached that tipping point. We've gone from the laboratory to commercial development. We've proven that it's sustainable, and as more players join the game, we simply are gaining momentum and establishing that place in the markets. And I'll go to my last slide, which I think is the end. Yeah, so thank you very much for this opportunity to present this to you. At the end, there'll be some questions. I'm sure I certainly can address those for you when they come up. Thank you.
Great, David. Thank you so much. What a great presentation, and thank you for giving the global perspective. It really shows how much the market for hydrogen is advancing, and seeing that California is really pioneering in the U.S. And we'll be looking forward to a later discussion soon on how we can further accelerate the adoption of hydrogen technologies in the Northeast. So thank you so much for your presentation. So the next speaker I would like to present, well, first I'll introduce Steve, who will be introducing Bob Morton. Steve Russell is also a good friend to the Northeast Clean Freight Corridor Initiative. He is the coordinator for the Massachusetts Clean City Coalition. He's also the alternative transportation coordinator for the Massachusetts Department of Energy Resources. He's been the coordinator for Massachusetts since 2009, but prior to that, he's been in the fleet management industry for 20 years. He had been the fleet superintendent for the city of Keene in New Hampshire. And prior to that, he had been the fleet procurement manager for Windshields America. You also may know, Steve, that he organizes every year the Alt Wheels event, which is also a significant opportunity to learn about the latest and greatest alternative fuel vehicle technologies and all the great happenings in the New England states. All right, Steve, I hand it over to you. Thank you.
Great. Thank you, Alicia, for that nice introduction. Can you hear me?
Yes.
Can you? Great. Okay. It is my pleasure to introduce Bob Morton. But before I do that, a little background on biodiesel here in Massachusetts. We have an executive order where all the diesel vehicles run on B5. Several of the fleets across the state run B20. Harvard University, City of Boston, and would you believe that when these rock bands come into Massachusetts, it's our obligation to make sure that Dave Matthews Band, the Fish folks, all get B20 in their tractor trailers, so they claim they're green, and it's wonderful. They're still doing it, and just recently we've provided that fuel. So that's pretty exciting stuff. And so Bob Morton, who is the president of Newport Biodiesel down Rhode Island, is a real mover and shaker when it comes to biodiesel. He's a member of the National Biodiesel Board. He was recently recognized by the National Biodiesel Board for his great work trying to move things along in the industry. He was a leader in our Massachusetts and Northeast biodiesel grant that we received, and we pulled together all the principal owners of small producers of biodiesel. We had some great sessions here in the Northeast to really push the fuel forward. And it's a drop-in fuel, don't have to do anything with it, and it's my pleasure to introduce Bob, who will give you the real skinny on biodiesel. It's yours, Bob.
All right, thank you, Steve, and thank everybody for the opportunity to talk about biodiesel here, because I really feel that biodiesel should be a part of this Clean Corridors program for a lot of the reasons that Steve just talked about, that we do get significant greenhouse gas reductions from using biodiesel, and it's a ready-to-go fuel with minimal infrastructure requirements and developments, and it can be used on vehicles that are operational today. So if we look at the next slide, we have our thing about saving cars and trees and everything like everybody else does. This looks at the total volume of biodiesel in the marketplace today, which is over 2.9 billion gallons, which is being used, and it averages 80% reduction in greenhouse gas emissions. But it's important to look, if we look at the next slide, of the types of feedstocks that we use to make biodiesel, and you'll see the recycled oils. In New England, that's the biggest source of feedstock for biodiesel. We don't use much soybean at all in the New England region, although we may import some fuel from the Midwest. If we look at the next slide, this is the carbon intensity values that the low carbon fuel standard uses in California, and you'll see that the used cooking oil on the lower left side of the chart is the cleanest, lowest greenhouse gas emissions that are available from many of these types of fuels. So by keeping to the used cooking oil sources in New England, I think that would be a good start. So let's go to the next slide. And this talks about really the drive for diesel that's going on. I mean, diesel is really a primary power source now for heavy-duty vehicles, both on road and in the marine and rail environments. And we think that that's going to happen or continue for quite some time. And so, really being able to make use of biodiesel to reduce the greenhouse gas emissions from the diesel vehicles that are out there would be a key objective, I think, of the Clean Corridor program. So let's go to the next slide and see how biodiesel ranks among the fleets for alternative fuel usage right now. And this has got a couple of surveys that's showing that 18% of the fleets use biodiesel now, and that's increasing over time. So, as we try and get more biodiesel available to those fleets, I think it's going to just grow over the next few years. And let's go to the next slide and see why biodiesel matters to fleets. It's the least costly option to green your fleet. As we said, you can use existing equipment and infrastructure that's already there, and it's a fuel that has been working fleets nationwide for more than 20 years. And because we have a quality control system called BQ 9000, we do have a lot of OEM support for using biodiesel in modern vehicles today. So if we look over to the next slide, you'll see that in the class 5 to 8 vehicles there, most of the vehicles used on the freight area and on road, nearly 90% of them support a B20 blend. So that's a very important thing and a result of having the high quality fuel that we do have today. If we look at the next couple of pages, you'll see all of the OEMs that are supporting the B20 blend. So that's a really important thing. If you get to B20, then you really do have a significant greenhouse gas reduction by blending biodiesel with petroleum. So we have this group here and a second group on the next page, see even more. And then finally, we can go to look at the different General Motors and Ford. From 2011 on, General Motors heavy-duty products all are qualified and approved for a B20 blend, and Ford is doing the same thing. On the next page, you can see what's going on there. So a B20 blend is really a key factor for going forward. And one example of a fleet that's using a lot of biodiesel is on the next page, where you have New York City has over 9,000 diesel-powered vehicles that are using biodiesel blends consistently, and they've created a 19% reduction in carbon emissions since 2005, and they're aiming for, again, an 80% reduction by 2050. And as Steve mentioned, there's a lot going on in New England of other fleets that are using biodiesel. The Boston Ducks are using it, both Harvard University, University of New Hampshire are using it, and Mount Washington Cog Railway is using it. So it already is available and in use in the New England area. Let's look at the overall distribution of biodiesel retailers on the next page. And we see here throughout the country that it's obviously quite a broad range of people that are using it. Again, we mentioned earlier about Love Truck Stops. They're the single biggest buyers of biodiesel in the U.S. And so that they're mostly in the West Coast and stuff, or western part of the country, but they certainly use it all the time. Pilot is another big truck stop thing. They're all using biodiesel blends up to 20%. There's a couple of really big state initiatives that are going on, particularly in the Midwest, where you see all those stops in the north part of the Midwest. Illinois has a mandate for B11, 11% biodiesel in all of their fuel, and Minnesota has B10, a 10% blend in the winter, going up to B20 in the summer. So these things are all happening, and we need to get more and more of these higher blend mixtures to be working for the future. So let's look at the next page at the Northeast retailers. We're a bit behind. So this is where I think that the Clean Cities program and the Clean Corridors could really make a bigger difference to be able to get more of these retailers online. If you look in Rhode Island, where we are, there's only 2 places in Rhode Island where you can buy on-road biodiesel. So we really need to work on that. And the issues to consider is that it really shouldn't be too big a job, because you can use standard pumping hardware, local sources for the fuel, and you know, we can really get that down there and be able to have tanks that have a standard blend. I would recommend that we just go with the same thing that Minnesota is doing, of a B10, say, from October to May, and a B20 from June to September. And it would be a very simple thing to put these sorts of fueling facilities at any of the standard stations that are around. So to be a part of this program would, I think, be a great idea to keep biodiesel and get it more used. So, I mean, this sort of summarizes where we are with biodiesel, and I thank you for the opportunity of being able to present this.
Great, thank you so much, Bob. Excellent presentation and a very nice overview, and definitely we want to discuss today how we can further build out the infrastructure and opportunities for producing biodiesel and utilizing biodiesel in the Northeast. So thank you so much for being with us today. And I just want to thank all of our presenters that have definitely put a lot of time and effort into their presentations, and really speaking uniquely to our Clean Corridor efforts and how we can partner together to move these very clean alternative fuel technologies and infrastructure, the needed infrastructure in the Northeast. So thank you so much, Bill, Leo, David, and Bob. You guys are fantastic. So now we've come into that time of our webinar, which is great. We do have some time. We have about 25 minutes for a work group discussion. And I'm going to first stop, and I think maybe, Abby, I'll check in with you on questions that may have come in while we had our presenters giving their presentations. We do have a few questions that we developed, but first maybe what we'll do is stop, and Abby, if you want to go ahead and maybe bring up some of the questions that folks had raised during the call today, that would be great.
Great, I'm glad to do that. Can you hear me okay? Okay, let me just go in order. We're going to back up then to the CNG portion of the presentations. One that came in from Mike Hornsby, who's with New Jersey Bureau of Public Utilities. That one came in right after Bill's presentation, but seems also to be for Leo. what percent of CNG in vehicle use today is renewable natural gas?
Was that directed towards me, Abby, or towards Leo? Or should we both take a shot at it?
You
we'll probably
go
give
first.
different answers. I think it varies depending on where you are in the country. On an overall basis, the percentage is probably, I'd guess, somewhere south of 20% at this point nationally, and that's including all market segments: transit, refuse, heavy duty, over the road, heavy duty regional, and light duty. There are certain states like California which have programs that incentivize the use of renewable natural gas where the percentage will be much higher. It could be 70 to 80% in California. Leo, I'd be interested in your thoughts.
I think your numbers are very accurate. Our company, almost every gallon we sell in California is renewable natural gas, so it depends on where in the country you are. And the reason that is in California is because it's profitable to sell it there. But there are incentive programs that could be carried from California to the rest of the country that would make it profitable for everyone to do it. And then the question will become, how do you get the sources to sell that fuel? And it's landfill, it's digesters, it's a myriad of ways to get that fuel into the system. But Bill's numbers are pretty accurate.
Great. And another one that came in, this one during Leo's presentation from Mike, what's the difference between LNG and LCNG?
So LNG is a supercooled form of natural gas. It's minus 260 degrees. What we do is, if there's no pipeline available, we will bring LNG to a station, and then we have what we call a vaporizer, and it heats the liquefied natural gas to a vapor, and then we compress it and send it out to the vehicle. So it's the same gas, it's just heated up from its liquefied form or its supercooled form to a gas. And just so everybody knows, when it hits the engine, it's always a gas, no matter what form of gas you're using, whether it be LNG or CNG. When it gets to the engine, it's always a gas.
So you're saying, Leo, that during the time it's dwelling in the warm state, it's LCNG?
No, when it's cold, it's LNG. We heat it up to make it LCNG. We actually heat the gas itself to make it LCNG.
Okay, great. Thanks for
it's sold as CNG.
Right. Okay. We'll see if Mike sticks his hand up again, but I think that sounds like it answers his question. Another one that came in, this one from Aaron Walsh of MetLife, who's a sustainability analyst for that company. This one came up during Leo's presentation. What about methane emissions from natural gas? What are you doing to reduce methane emissions? And I guess this could be for Bill too.
Well, people always, I'll take a quick one and give Bill a shot at it too, but people always talk about methane emissions. Technology has improved significantly, and especially, with CNG, there's no boil off. With LCNG, there was a time when that was an issue. Because of improvements in technology, as I put in my preso, it's really not an issue anymore. As far as releases from the source itself, the industry has improved because of EPA requirements and continues to improve, and hopefully we'll get to a point where there is zero methane emissions. But today, I think we've greatly reduced, I know that we've reduced methane emissions from our station perspective and from a tank perspective.
Yeah, I'll just put a little bit more color around that, Abby, if I could. So Leo had a pretty good slide in his presentation that showed from the production source all the way through the nozzle tip on the compressed and liquefied natural gas value chain. And along that chain, I believe, is probably where Aaron was asking his questions. There have been some studies out there that have talked about releases of natural gas done by the Natural Resources Defense Council into the environment. But those releases are primarily done on the upstream side, or have been quantified primarily on the upstream side and on the pipeline side, delivery side of the natural gas value chain. And as Leo mentioned, the EPA and other FERC and other transportation entities are looking at trying to minimize those emissions from those sources. They've been very active in that over the last couple of years, and I know the industry has done a great job. The numbers that were published in the NRDC report were very contentious. They come from a variety of different sources, and I think a lot of people that are actually in the industry and that work it would dispute it. But that aside, There's a lot more data that's being collected on that, and I think as time goes on, we'll find that those emissions are being minimized, and the numbers that we do present to the public will be better than they have been in the past.
That sounds good. All right, we've had some more questions coming in. And let's see, I need to employ my bifocals to read these. Bill Zobel mentioned renewable natural gas. I thought the slide showed those as landfill sourced. Is that correct? If so, I thought landfill gases were primarily methane. Is that true? This is from Arthur Klimas, who's Bridgeport Port Authority.
Hey, Arthur. There are actually a variety of sources of renewable natural gas. Landfills are one of them. And the gas that comes off of the landfill is primarily a low BTU gas. It's got contaminants in it such as that include nitrogen, CO2, water, and methane. And there are systems on the back end of those gas collection systems that clean up or take out all of the nitrogen and CO2 before they can put that gas into the pipeline. So that's how gas is basically taken off the landfill and put into the pipeline system for use as natural gas, either in your home for heating or in your vehicle for the compressed or liquefied gas. I listed 3 other sources on my slide. Those are primarily anaerobic digestion sources, or AD sources they're referred to. Those can come from wastewater treatment plants, where they take the anaerobic digestion gas off of those plants and do basically the same thing. They clean up the water and the nitrogen and make it just natural methane and put it into the pipeline system. And there are a variety of new technologies that are now taking animal wastes, manure, and other feedstocks and digesting those in these large capacity systems that will also take that gas, clean it up to pipeline standard, and inject it into the pipeline. So there were 4 sources on there, and all of which are a bit different, a bit unique. They all have their own carbon intensity value input into the transportation space, but all generated with different technologies.
Okay, that sounds authoritative. We have a question for Bob from Jeff Morrison of Cadmus. Why should policymakers and planners prioritize biodiesel over renewable diesel?
I'm not sure that they should, to tell you the truth. They end up with about the same properties, and it's really just a matter of how you use it. And really, there are not that many domestic renewable biodiesel plants right now. Most of the renewable is coming into California is from Indonesia and that sort of thing. But a lot of the big biodiesel producers do have renewable diesel plants that they're developing as well. So I mean, I think they both end up with the same general properties, although the renewable even has better temperature values than situations than biodiesel. But it's basically, in the end, it's the same impact on reducing greenhouse gas emissions. And I would keep both fuels going.
All right, that sounds objective. We have a question from Wendy Lucht of Ocean State Clean Cities. How can the Northeast Diesel Collaborative and other regions advocate that biodiesel, i.e. B20, be added to the Federal Highway Alternative Fuel Corridor designation process? I'm sure you've tried, Bob.
Yeah, I have. And I mean, I don't know the answer to that. I mean, I would like to see that whoever is running this program and trying to get it going considers biodiesel as being a way to go. And I think, you know, a National Biodiesel Board is ready to work with anybody to help establish the infrastructure to do that. So, you know, I can just encourage, and I appreciate the opportunity of being able to discuss it on this workshop.
Well, this is a good place to make a small distinction. The Northeast Diesel Collaborative's Clean Freight Corridors Initiative is not one and the same with the Federal Highway Alt Fuel Corridor designation process. We are, as Alicia said, I think at the outset, and we've said on other webinars, fuel neutral. I think Federal Highway felt bound by the authority under which they implemented the Alt Fuel Corridor project to basically focus on some fuels at the neglect of others. And I think Diane Turchetta, who's our liaison to that program and really the head of it, has said that it wasn't her decision to make. But we do want to entertain everything that's practical for freight in the Northeast and makes sense for deploying in a sort of corridor framework. So next question is from William Rose from New Hampshire DOT. Is there a reduction in engine maintenance costs between CNG and diesel? If so, by what percentage?
I can touch on that. We get a lot of different answers on that in this space. We've got folks that run a lot of miles for the U.S. Postal Service on natural gas. The Postal Service is a big and growing natural gas user of over-the-road fleets. Most of our folks in that segment claim that the cost of ownership or the cost per mile for natural gas tractors is the same or less than a diesel tractor. Folks in other duty cycles that run different kinds of operations will tell you that it's more. So I guess my short answer to you is it varies and it depends on your duty cycle. In terms of more or less, I don't know that it's that much more or less than what you're paying today, but there is a difference in many cases. Leo, if you have anything to add on that, go for it.
I would have to agree with Bill. Depending on the user and their duty cycle, it can be more or less. I've heard people tell me it's 4 cents a mile more. I've heard people tell me it's a penny a mile more. And I've heard people tell me it's a nickel a mile less. It's all about where you do your maintenance, who you do your maintenance with, and what cycle you run.
This is Bob. I would just want to say relative to regular diesel, biodiesel has greater lubricity, and there is certainly less, cost for running if you use a blend of biodiesel than just using straight diesel. But I don't know what the number is. I know that it's better.
I'll just add one more thing. What we have seen is that where fleets have committed the majority share of their tractors over to the natural gas product, they have better results. Where they have just kind of dabbled in it, a few trucks here, a few trucks there, the mechanics that generally maintain those vehicles make it that much more difficult because they really don't want to deal with the change. And so in some cases those represent where some of the higher numbers are coming from. But for fleets that have gone 90%, 100% conversion over to natural gas to move their products, they're seeing lower costs across the board.
That seems to make sense. I had a question of my own. I hope you'll let me exercise my organizer prerogative. This was for Dave Edwards. I was curious about which highways the 12 Northeast stations that are going to come online in the next year or so between New York and Boston are along, and sort of follow-up to that is, do you plan to work with the New York and Massachusetts DOTs and others in that corridor to apply for alt fuel corridor designation under the next round of designations for a hydrogen corridor?
So for your first question, the corridors between New York and Boston, so one of our stations is in Hartford and one of our stations is in Providence for the connectors, but I'm not sure which highways they're along. I know that they're on major highway exits, but I don't recall which specific highways they are. Keep in mind that the first generation of the stations are aimed toward the local people who are going to own the vehicles rather than for the long distance commuters, for example. And so we've put them in neighborhoods where the auto manufacturers essentially want to sell the vehicle so that people will have a local station. Our next generation of stations in the Northeast will start to be aimed toward the transportation corridors. And so yes, I think on your second question of will we be part of that system, I believe that the answer to that is yes, we will become part of those corridors for next generation fuels. Although it's a little bit premature and to some degree has to be driven by the car manufacturers themselves.
All right, sounds fair enough. And I had one more question, and this one's for Bob. I think you've partly answered it in recommending that the Minnesota model would probably be the most practical one to adopt in the Northeast, 10% bio for the cold season, 20% for the warm season. Do you think that's going to work everywhere in New England? And do you think that, you know, that model is the only one that stations need to offer rather than, you know, the more disparate offerings 5, 10, 20 year-round?
Well, I was just sort of looking at it from a practical point of view. I mean, to make it simple, I was just suggesting the 10 or 20% blends. You know, to have a blending pump and have an independent biodiesel tank that blends with petroleum, it's going to be a lot more expensive. You know, and I think that the easiest thing for a station is to just make it simple and just go for the single blend in the winter and the summer. And I think that's been very practical in Minnesota. I'd say we use B20 pretty much all year round here at Newport Biodiesel. But just to be safe for people that are going to be in cold weather and stuff like that, a B10 is just a safer way to go, I think, is what it boils down to. So you don't have any cold flow issues at all.
I will remark that as SmartWay Transport Partnership Liaison here in New England, there's a very curious, encouraging preponderance of users of B20 up in Maine. So obviously some people can make it work even in cold weather. I guess they add some kerosene, but they make it work.
There are ways, but you want to be sure the reliability of the fuel is there, and you don't want people who aren't doing that sort of thing have any issues. You know, so that's why I think the B10 in the wintertime is just the safest, easiest way to go.
All right, I see one more questions come in before, and then I guess we'll turn it over to the big picture discussion questions. This one's from Craig Peters from Manchester Honda, Hartford. The question is, Hartford Hydrogen Station located off I-95 Jennings Road exit. Oh, it's not really a question. It's just telling us where it's located. Thanks, Craig. Okay. So let's turn our attention to the slide that Alicia has showing up here. These are sort of like, where do we want to go with all this information as a group? So let's see if I can clear my screen so I can actually see our questions properly. The questions are, you know, what else do we need to know beyond what you folks have told us today? This is a question for the broader audience. In terms of, you know, how these fuels work, how the vehicles that use them work, how they become available, and how people actually use them. What about that do we need to know before we take a next step and say, okay, let's build some stations for this and that, serving these and those fleets? The next question is basically, who else do we need to bring into this conversation to make it work in terms of both funding and siting new infrastructure along freight corridors, and incentivizing fleets to basically convert or replace their vehicles to enable them to use fuels, and that is obviously not necessary in the case of biodiesel. And then the Northeast Diesel Collaborative's Clean Freight Corridors initiative is, you know, been operating as an educational and sort of convening platform across disciplines, state boundaries, types and levels of agencies, public versus private. You know, what is the ideal role for this group to carry this conversation further? Because, you know, left to everyone's own devices, natural silos spring up, a certain lack of coordination and siting and other means of providing for alt fuel vehicles and fueling tends to happen, and we want to get beyond that. We want to get to collaboration and coordination and efficiency. So I guess we can just sort of open it up, and we can unmute you if you have any thoughts on that.
Abby, I'm certainly willing to kick that conversation off. This is Bill. On the first, you know, your first point, you know, kind of what the next steps are here. I mean, I try to identify those in the back end of my presentation. We can certainly review those later at your leisure. But looking at ways to try and tie people together, integrate financing mechanisms that help makes it easier for people to move into alternative fuel vehicles, which are obviously more expensive than traditional petroleum models, and develop infrastructure. Money will certainly help drive that program, especially in today's economy with a minimal differential between petroleum fuels and most of the alternative fuels we talked about today. In terms of who else we might want to incorporate into the mix here to develop the most robust program that you can, I would certainly encourage everyone to get involved with the state agencies that are in charge of those monies and the folks that distribute those monies, and ensure that the criteria by which they distribute those funds is well aligned with the goals of this program. In a lot of cases, the states are doing their own thing and the federal government is doing their own thing, and the two roads never meet. So the ability of state level money and federal level resources to come together, I think, will result in the best overall program for everybody.
That sounds good. Anyone else want to opine, chime in?
And this is Dave from our... Go ahead.
Go ahead. This is
so
Bob.
From a hydrogen perspective, where we've brought new fuel into California, for example, we've seen a difference in the Northeast where decisions tend to be made at a lower level on a local basis earlier in the process. And in California, having a high-level roadmap that then feeds down to the local communities and then feeds into our roadmaps for how we introduce has been really, really helpful for us. We see less of that in the Northeast, and that you might have different laws in different states and different regions that have different implementations, and they don't all have consistent roadmaps. So if any CFC can play a role in helping make that more consistent and having long-term visions and having the customer, or sorry, the advocacy aspect of that, I think that would be very helpful for us.
That is very wise, and in fact, we're working with other coalitions to sort of harness their synergies as well. Like she couldn't be on the call today, but Mary Grace Parker of the I-95 Corridor Coalition, for instance, can bring a lot of the Northeast state DOTs together on this. The Transport Climate Initiative, which is more focused on electric right now, they tend to bring the state environmental agencies together on, fueling issues. So we're trying to reach out to all the relevant coalitions to kind of leverage their unity. Other reactions?
This is Bob. I was just going to say, I'll put in my plug for the Clean Cities groups that I'm sure that you're working with now. But my experience is that they've all had very good contacts with their own state legislators and entities there. And by coordinating all that together, I think would be an important way to get those different state agencies all working in the same way.
Very good point. In fact, Erin Russell-Story has been an active participant. She's the Northeast Regional Coordinator for all of our Clean Cities coalitions, but they are definitely a very strong partner in all this. In fact, they're sort of in it with us, so we don't have to reach out to them. They're here. Other thoughts? I heard more voices. All right, well, I guess, we're almost at the end of our session today. Alicia, do you want to kind of close us out or add a thought?
Yeah, I guess I had a thought to add, and that is we want to help make our, our partners and their efforts in focusing on advancing the fuels for natural gas, for hydrogen, for biodiesel. And, a lot of challenges are how do we, get the supply to meet the demand, and then how do we create the demand. And I guess, maybe you can share some lessons learned with us in terms of, how can we, one, better inform, end users about the benefits of these fuels and the location of stations that they can access. How do we help build more demand for these cleaner fuels? And then, I know we're talking about how we can, as a platform, support, promoting clean corridors and the integration of more stations in the Northeast. I guess, how can we help create more demand, and how do we more effectively reach out to our end users to share with them the benefits of these fuels? And then we'll close after that.
It's Leo again. It's a great question that you asked there. At the end of the day, nobody says to themselves, hey, I want a dirty truck running through my neighborhood, or I want, a diesel particulate in the air. We know that places that have heavy truck traffic have increased levels of asthma and cancer and all kinds of different problems physically, health issues. So what can we do to make those, especially like port areas and high traffic truck areas, cleaner? And at the end of the day, listen, none of us is going to say no to money to build infrastructure. Not us, not Trillium, not any other company out there. But the users, they see an increase in the price of an incremental increase in the price of their vehicles, and that's really where the agencies have to help these guys, guys and gals, because everyone will tell you, everybody you go to, everybody you pitch to will say the same thing. I'd love to go green if it doesn't cost me a penny more than diesel. And so in this environment, because diesel prices are so low, it's difficult for a company to make that investment hoping that diesel prices go up and that it pays off for them in the end. So we need to help those end users get the money that they need. And if there's a demand, we're going to build a station, Bill's going to build a station, everybody's going to build stations if there's demand. Nobody's going to say no to building a station, but you have to create that user, and the user is created by making sure that their incremental costs are at least on par with a regular diesel truck.
Great, thanks, Leo. Any other thoughts to add before we close this afternoon? I think, Leo, you really hit it on the head there with the help of incentives. And there are incentive programs to help move forward clean vehicle technologies. I'm currently managing a $19 million incentive program for medium to heavy duty vehicles in the state of New York. Susan McSherry is also managing an alternative fuel vehicle program in Hunts Point. Incentives are really helping us to move these technologies forward, and like Bill was speaking earlier, when you have the vehicles, then you create more need for more infrastructure. So, we do have that challenge with this chicken and the egg, but really incentives are a very effective tool. And I think, going back to looking at the funding resources that we see in front of us with the VW settlement funds, that's a real opportunity for us to think about. And certainly we want to work with our partners in looking at how we can coordinate with our states to dedicate VW settlement funds to the advancement of these clean vehicle technologies and infrastructure. So, all right, you guys, well, we're 3 minutes past our 90-minute segment, and I appreciate everyone who's been hanging in there, and I hope you enjoyed our conversation and discussion. I think we have a lot of work to do, and much help to our speakers today, who really have provided good information and perspective on how we move the region forward with these fuels, and certainly look forward to collaborating with them more closely and effectively. So we will be, this is a recorded, just so everyone knows, we record these conversations and we upload them on our Northeast Diesel Collaborative website, which is northeastdiesel.org. And that way it's an opportunity for folks who may have missed the conversation. They can go back to it and have that to their access, as well as, it's just we want to use these opportunities as information that we can continue to share, but we also want to continue to build upon the conversation so that we're moving our region forward in a meaningful way. As I mentioned earlier on, our next webinar will be on July 27th, and we'll be looking at electric hybrid and electrification of TSC, or truck stop electrification at truck stops. That will be our next conversation, and we look forward to bringing you all back to a good number of good presentations from folks that we'll be inviting to partake. But thanks again, everyone, for participating, and much thanks to my presenters and my Clean City coordinators who helped introduce our fine panelists today. Much thanks to Susan, who helped organize today's webinar, and Abby, who just always tremendous. We look forward to talking to you next time, and have a great rest of your week, everyone.
Thank you, Alicia. Thank you, Abby. And thank you, presenters.
Bye now. Yeah,
bye-bye.
Excellent presentation. Bye-bye.